All right, here is 5.3.2, or I might refer to it as 5.3.2 day two, um, depending on how I've expressed it. So here we go. So the first thing we have here is a little bit of a warm up. Why don't you make sure that you take your time to pause and to try these. If you're not practicing, you're not going to get better here. All right. Hopefully you've tried this. All right, we need to find the area of this shape. Remember that we talk about area of rectangles as base times height equals area, okay? Base times height equals area. And the base of this rectangle is 10 and 1/4, right? So 10 and 1/4 times the height, and the height is 4 and 2/5. 4 and 2/5, okay? We'll zoom in here. We got 41/4 times 22/5, and stuff that we had practiced before. And what we need to do is multiply our numerators, and I will let you take your time to multiply these numerators on your own, and denominators to get that. And what we're going to do is we're going to look for how many 20s go into 902. And in here, this one's a little tricky at least, so I'm going to put it on the side here. Whoops. And I have 20 into 902. I have 4 that's going to go in here for an 80, and I subtract, I got 102. How many 20s go into 100? 5, 102, I should say. There we go. We got 2 left over. So that's going to equal 45 and what? 45 and 2/20ths. Whoops, sorry about that. We should reduce 2/20ths all the time. That's kind of what I was doing in my head. We can divide both of these by 2. And so we have 45 and 1/10. What are our units on here? These are square centimeters. Okay. Pause the video and be sure to try this one right here. All right. As I look at this one right here, I would probably say that you can cut it to whatever you like. I will suggest, though, that finding the other side in this case is going to be awfully helpful. And if we know that this is a 1 over here, then if I were to extend this, that this would also be, whoops, if this is 1 and I were to extend this, then I could make this also 1 centimeter. If that is truly the case, remember that the whole thing right here is 5. That would make this piece 4 centimeters, okay? Because that would be 4, and this would be 1 centimeter right here, okay? I'm going to shift that over. That'd be a little bit better. Notice how we can see now the 1 and 4 to give us a total of 5. That upper rectangle, or a square as you'd want to mostly refer to it, would be its base is 4 and its height's 4, so its area is 16 square centimeters. And in that bottom rectangle, its base is 7 centimeters and its height is 1 centimeter, so it has an area of 7 square centimeters. And to find that total area, we would add those two sides to put that together, and we should have 23 square centimeters. All right. Let's get out of here. What I want to talk about today is area of parallelograms. And one of the things that I'd like you guys to, that I would have had you do if you were in class, is you would have taken a paper parallelogram, and you would cut that parallelogram, and your goal is to make it into a rectangle. And this would be one of the things I would hope that you would do eventually, is to cut it as such, and then put that triangle over there. And what you find is the height of that parallelogram is never changes in there, and the base is just that bottom part. And now we know how to find the area of that rectangle, or now we can find the area of the parallelogram, excuse me, because we know the area of any parallelogram. I'm sorry, of any rectangle. Okay, let's get into the lesson today. The lesson is, how can you cut and rearrange a parallelogram to create a rectangle? Well, we just kind of talked about that. One thing I would want to note is, notice we have B for base, H for height, C, sorry about that, I bumped it. C is our height, or not, our side length there. And sometimes you're going to see parallelograms that have those values in there. They are useful for certain calculations of parallelograms, but when we go to find the area of parallelograms, we do not need that value. We do need it for a rectangle. So we will say that area of a parallelogram, this is really important, and I feel like should be written down somewhere, area of a, and I'll even write, this is what we call subscript. Um, it is, it's kind of like below, like if we have B, what in the world? I'm sorry, I keep bumping that on the side. If we were to say like H2O, right? In water, we have that 2 is what we call a subscript. So area of a parallelogram, that's in subscript. So we know what the area is for, is base times height. Base times height. Okay. B is the base, and H is the height. Such an important one to that I would write that down to make sure you have that right. Not C. Notice how C doesn't play into that. Okay. Find the area of this parallelogram. We talked about that. All right, why don't you test that out here right now? Each time I get to a new shape, pause the video, find the area, and then come back and check your work. So in each of these cases, let's make the base B blue and the height is green. How about we just do that? All right. So our area equals base times height, right? And our base in this case, and I thought my college professor did a really good job of writing this, he'd always write out the equation, and then he'd write the variable that we don't know, in this case b, and he would write that out below. And then, so you always knew what variables were what. So um, area is equal to 6 times 4 for a grand total of 24. 24 what? It's area, right? Square feet. 24 square feet for this one. Okay. Find the area of this parallelogram. Now, you might be inclined to suggest that the base has to be in the horizontal and the height has to be in the vertical, and that's not always the case. The base is always something that we want to look at, and we would like to say is the one outside length. So in this case, we're going to make our base 9. Whoops, sorry about that. Our base is going to be 9 in this case. And our height is always something we haven't talked about a ton before. It needs to be perpendicular. Sometimes you see a little part of a square, almost, if you will, right there. It means perpendicular. It's 90 degrees to it. So our height then in this case will be the 5. Okay, so area equals base times height, and our base is 9 inches and our height is 5 inches, right? So our total area is is 9 times 5 for a total area of 45. Again, what are our units? Our units are square inches, SQIN. Find the area of this parallelogram. What's really nice or unique about this parallelogram is we still have a base here, but notice the height can sometimes be listed outside. And so when we go to put, when we go sometimes to find that, sometimes you're like, oh man, is it part of it? Is it not? What? No, sometimes those bases are just listed there. And, I'm sorry, those heights can be listed outside of the object. And just kind of use those lines to illustrate that. Also notice that the little rectangle that I had just mentioned, and that little rectangle is, oh, I didn't put the actual number in there, did I? The actual little square, I mean, sorry, in that little corner indicates perpendicular, okay? So area equals 7 times 3, which is 21. 21 what? Square inches. Find the area of this parallelogram. Now we add a little dynamic to this, right? This is a little different. Base, sometimes you might be inclined to say this is the base. Then which one's the height? Do you say it's the 6 or the 7? I'm not sure. Well, it turns out that we have to make sure that our base and height are always what we call perpendicular to each other, as I said earlier, and that little thing indicates that. So when we are highlighting these numbers, we always want to make sure that they are perpendicular, because if they are not, we are unable to multiply those. And so the trickery in this one, if I could use such a phrase, is the 9. The 6 is actually our base, and 7 is our height because they are both perpendicular to each other. 9 is just I guess you could say it's a side length that's in this case here to distract you. And remember when I had that C thing way up above? That's where that came from. And it is, like I said, it's important, but it's not important for this. And maybe you're already thinking in your mind how important it would be, like what would it be used for? And in this case, I hope you're starting to figure out that we could use it for perimeter. Sorry, I want to keep saying perpendicular, but it's not. Here's one more. I'm not going to color code this one, right? Our area equals our base times our height. Base equals 10 feet, and our height equals 2 feet for our area to equal a grand total of 20 square feet. Okay. All right. If you know the two sides of a parallelogram, if you know two sides of a parallelogram are 12 and 16, is that enough information to find the area? Take a second, think that one through. Well, what do you think? Is that enough? I hope the answer to that is no, it's not enough, right? 12, remember, is a side length. What do you need to find all of that? Height, right? Our height would be okay. Or, as we were showing here earlier, the height can always be what? Outside, right? So we don't have a height. Since we don't have a height, we would need that, right? Now, yeah, let's leave it at that. All right. So when would we use the side length of 12? And that's where we were talking about how we could actually find the perimeter, right? And the perimeter in this case would be 12 plus 16 plus 12 plus 16 to give me a grand total of 28, 56, I believe, 56. And we'd have to call it units. Hopefully I did that right. If I didn't, make sure I do it right. Ha. How can you find the area of any parallelogram, right? Any parallelogram means what? We need to have the base and we need to have the height. We need to ignore the clutter. We need to ignore the clutter, which, by the way, the base is also can be on top. The base does not have to be the bottom. I could simply say the base is the 8.5 on top because why? I know that it is perpendicular to perpendicular to that too. Okay, all right, I hope that wraps that up. So the area of any parallelogram is base times height because it is the length and width, but we don't call it anymore, the base and height of a rectangle. All right, have a good day.